Yes, very good. Thank you. So I like your films which you produce. I think they are very provocative and interesting. With me like in a primary role, of course, but still you are also seen there. So please, now the second part will be devoted to the problem, the question, the scientific revolution of the 17th century. So, I think that perhaps you will be a little bit surprised that we leave antiquity and pass immediately to the 17th century. But I did not create this program, so I have no responsibility concerning these questions. I didn't invent them, so I take them as they are. They are sort of confirmed by our authorities, and so I have no other choice than to follow the program. The scientific revolution of the 17th century. So, very good. And Key, is your name Key, or it's your surname? Key. What is your name? Please, I don't hear you. Switch on the microphone.
Oh, yes.
How you pronounce your name?
Qi Xiaoli. Qi.
Xi.
Xiaoli.
Li. Okay, so yeah. How do your parents call you? Li?
Yeah, okay.
It's possible?
Yes.
Li?
Yeah.
Okay, very good. Thank you. So thank you for attending. So we'll have this scientific revolution of the 17th century. And who coined the term scientific revolution of the 17th century? I'm very proud to announce that this term is coined by my compatriot, Alexander, Russian historian of science, Alexander Koyré. Well, you can find information about him, or I can also find it on in the internet and send it to you. Just a moment. Now we can demonstrate the screen. Okay. So I will not demonstrate the screen because it is prohibited for me, but I will send the link to the Wikipedia article in chat. So you can, those who can demonstrate the screen can do it using this link. Alexander Koyré. So he was born in a small Russian city of Taganrog, which perhaps most of you don't know, Taganrog, but still this city exists in Russia. It's not a big one. It's on the Azov Sea in the south of Russia. And when the revolution started, I mean the October Revolution and then the Civil War, Alexander Koyré preferred to emigrate, and he left Russia for forever and settled in France. So his surname, initial surname was Koyransky, but the French couldn't pronounce such a long name. And so he changed it to more short form of koire, which is for French more palatable. You understand? Palatable. You understand this word, palatable? Maybe I will find this word in the Cambridge Dictionary. Maybe I pronounce it not Cambridge. Nah, we'll see. Well, palatable, I'm sorry.
Palatable.
Palatable. If food or drink is palatable, it has a pleasant taste. Well, it is used mostly for food and drink, but also indirectly it can be used for sweetness in generally. So we can say that your name sounds sweet, okay? So your name is palatable, okay? And if your name sounds queer, you can say it sounds impalatable, okay? You cannot sort of swallow it, okay? So this, well, my surname is maybe also hard for you. So but if you like a person, little by little, you get accustomed, sort of his name and surname sounds more and more palatable to you. And in the end, you start to love it, even how it is pronounced in a foreign language, say in Chinese or in Hindi or in Arabic. But you still, and especially when people give you the meaning of their names, because most names have meaning in their native language. For example, Aynur, Aynur in Kazakhstan, it means the moon, the moon, Aynur. Okay, so well, so you can, from the names, you can get more and more information about people. Well, returning to Korea, he first taught Russian philosophy and Russian literature, but then he sort of changed his topic of his research and started researches in history of science, and was became very famous. And in 1943, he wrote the article about the scientific revolution of the 17th century. And so in this article, which appeared in 1943 in the Journal for the History of Science, starting from this article, we can speak about scientific revolutions. Well, generally, revolution is upheaval, yes? Upheaval. You understand upheaval? Upheaval. Well, I can find the word in the Cambridge Dictionary. Upheaval. So we'll see how it is pronounced.
Upheaval.
Upheaval. A very big change that causes difficulty or confusion. This is the definition. Upheaval. This is the definition given by Cambridge Dictionary. A very big change that causes difficulty or confusion. Well, at first, revolution was used in as a political upheaval or political change. For example, the English speak about the Glorious Revolution. You know this Glorious Revolution, which the change of dynasty. The Stuarts give way to Hanover dynasty. The Glorious Revolution. It happened in 1688 in England. Then followed the French Revolution of 1789, the French Revolution, the Great French Revolution, as they say. And it started from the storming of Bastille, this famous fortress. And now this 14th of July is the holiday in France, which started the French Revolution. And we have now our October Revolution in Russia, and which was made by Lenin. Okay, Russian Revolution. Revolution. But what is revolution in science? What can we think? Because science is a very peaceful enterprise. How can we find revolutions in such peaceful enterprise as science? Well, you, in the quietness of your laboratory, you work day by day, and how can a revolution happen there? But in reality, it did happen. Well, for example, the famous German physicist Röntgen was also doing his peaceful research in the laboratory, and then he found out that the new rays, which he called X-rays, can come through his, say, his hand, and if it is X-ray my hand, you will find this wedding ring, yes, but also you will see my bones, you see. So there was this was the first photo made of a hand, I think, of Röntgen's wife in X-rays, and you can see the bones and the ring. I don't know whether it's a wedding ring or some other, but you can find it in also Wikipedia dictionary devoted to Wilhelm Röntgen. So sometimes in this quietness of a laboratory, a true revolution can take place. Revolution meaning near the complete change of our views about nature and about matter. In this way, not only X-rays, but also the invention of radioactivity by Maria and Pierre Curie was also a revolution, because it was considered before that atoms are unchangeable. You remember atoms, we spoke about them in the first half of our lecture. So the atomic theory developed by Dalton and Mendeleev held it, and Lavoisier and others, it held that atoms are unchangeable, that say atom of hydrogen or atom of helium or atom of, say, iron cannot be changed. It is eternal, and it exists, it is stable, and it exists forever in its form. But what Maria Curie and her husband proved was that the elements can change and dissipate, sort of, and give birth to new elements. And that's how she managed to create any, how to say, to find a new element which she called polonium, in name of her country, because Marie Curie was from Poland originally, and she liked her country. At that time, Poland was not an independent country. It was divided into three parts, one belonging to Germany, the other to Russia, and the third to Austro-Hungarian Empire. So there was no such country as Poland in the beginning of the 20s and the end of the 19th and the beginning of the 20th century, when Marie Curie, her surname, maiden surname is Skłodowska, did her research in Paris. So when she found the new element, discovered the new element, polonium, she can Anshita, it's okay, you can hear me or something stopped?
No, we can hear you now. Something
Okay,
has
very
stopped
good.
because of the low bandwidth, but now you are
Yes,
audible.
because today my wife was delivering lectures, and at some time she found out that
Video got hang.
so.
So okay, you can pause
Okay.
your video, and you can switch on your audio.
Well,
So that
if
it will take less internet.
Okay. Shut down the video. Okay.
Yeah.
Well, it's a pity you will not. You will not. You will not. You will only hear me, but you will not see me. Well, I'm trying to do it. Maybe I will again enter into this.
Okay, you can do that too. We can wait.
Is it okay now, Anshita? Is it okay?
Yes, is it okay?
Okay, so sorry for interruption, but we were just discussing very important thing, the revolution. So what is scientific revolution? Scientific revolution is the complete change of very widely held principles. For example, the indestructibility of atoms, that atoms are unchangeable and they exist in the same sort of shape and with the same qualities for all eternity. And you cannot change these atoms. Say, for example, you cannot change hydrogen, you cannot change iron. But when it was found that, for example, radium was changed and it was unstable element, radium. So that was a revolution. Also, another revolution was our change of, how to say, addition of speeds. You understand? When we addition of speeds, the law of the addition of speeds, for example, it was proposed by Galileo. Proposed by Galileo. So what did Galileo propose? If we are in the system of reference that is moving with some speed, and then we move with some another speed within this system of reference. For example, if we are sailing in a boat and we are moving across the deck of the boat, then if you want to calculate my speed in the system of reference connected with the Earth, you should add speed of the boat and my speed with which I move, say, on the deck of this boat. So, natural at first, people thought that this addition of speeds is can be how to say, is universal and can be used even when we are dealing with the speed of light. And so they want, if we say that the Earth is moving around the sun with the speed 30 kilometers per second, then we can, and it emits, somebody emits a ray of light in the direction in which the Earth moves, then the speed of light will move with this. Then something will be added to the speed of light. So the speed of light will increase. The how to say, the net speed will increase. But with Einstein, Einstein said that there can be no speed that exceeds the speed of light. So you should somehow change the law of the addition of speeds. And so this principle, which was considered valid since Galileo, had to be, so was sort of falsified and had to be changed. And this was a revolution. It led to very important consequences. For example, if we accelerate the particle, so according to Newton's law, you can accelerate it forever, and it can exceed every possible speed. So, but according to Einstein, this particle can never reach the speed of light. So what is happening with it? How can we explain that the force is the same, the acceleration is the same, why the particle cannot exceed the speed of light? Only one explanation can be given, that the mass of this particle starts to grow, okay? And this growing of the mass of the particle hampers it reaching the speed of light, okay? So this sounds very revolutionary, that the mass can grow with the speed, because with Newton, we had no such idea. Mass was considered independent of velocity, okay? So, well, I just am giving you concrete examples of the revolutionary changes in physics, but also the same changes are in cosmology. For example, it was considered that the space and time are infinite, and then you can, if say you send a ray of light in the universe, it will go and go, and sort of its distance from the Earth, if we send it from the Earth, will be greater and greater and greater to infinity. But with Einstein's theory of general relativity, the space is curved, and so this ray of light will be held within a certain distance. You understand? It will never. These infinite distances are not possible in Einstein's universe, because Einstein's universe is closed. So there is you can imagine a maximum distance which cannot be surpassed in an Einstein's universe. And in Euclidean universe, three-dimensional Euclidean infinite universe, you can imagine infinite distances, okay? So this is a complete change of our basic notions with which, but these are examples of revolutions in science in general. But now we are speaking with Koire about scientific revolution of the 17th century. And here the revolution consisted in the disproving of Ptolemaic geocentric system by Copernican system, where not the Earth, but the sun was put in the center of the world. This was also a revolution because everybody agreed that, and in every civilization it was agreed that the Earth is somewhere in the center of the world, and that the sun is rising and setting and moving around the sky. So you cannot find any civilization, Indian or Chinese, where people would propose that the Earth is moving around its axis and the sun is still somewhere remaining still motionless in the center of the world. So it was quite new idea. And this idea was proposed by Polish scientist Nicholas Copernicus, okay? This was a revolutionary idea. So, not Koire, but another scientist, historian of science, Thomas Kuhn, American historian of science, he even wrote the book which was called The Copernican Revolution. Copernican Revolution. Well, this is interesting. Here is some, I would say, some mystery in this, or some play of words in this title of the book, because Copernicus himself, when he described his heliocentric system, he described it in the book which he wrote in Latin. And in Latin, it was called De Revolutionibus Orbium Celestium. So you see, the word revolution is somehow used by Copernicus, but not in the in our present sense of upheaval, but in initial Latin sense of revolvere. It means to move by circle, to rotate, rotation. You see? So at first, the word revolution or revolutio in Latin meant just rotation. So we can translate the name of this Copernican work as, sometimes it's translated also in Old English, on the revolutions of the heavenly spheres. But we can say also on the motion of the heavenly, on the circular motion of the heavenly spheres, or on the rotation of the heavenly spheres. So, but somehow this word revolution appeared with Copernicus, not in our sense, but in its former sense. But it is like ominous, you know, ominous. Do you know the word ominous? Yeah. I will give you the explanation from the dictionary. Ominous.
Ominous.
Ominous, making you think that something bad is going to happen. Well, not bad, but something unusual, I can say. Here it's not so bad, but we're speaking about some unexpected thing which is going to happen. So sometimes we can say ominous without this connotation of something bad, but just omen is a sign that's significant. Ominous as a synonym of significant. So something significant is going to happen. So from these revolutions of the heavenly sphere comes the Copernican revolution. So the upheaval in science, okay? So the change of the picture of the world, the change of the worldview. Because Aristotle, as I explained you in the first half of my lecture, divided the world into two parts: the sublunar world, and the heavenly world. And sublunar world is made of four elements, which I already described: earth, water, air, and fire. And the heavenly heavenly world is made out of ether. So you see, and ether, according to its nature, moves circularly or rotates around the center of the world. And the center of the world corresponds with the center of the earth. And the earth is described by Aristotle as sphere. So the earth is a sphere, and the center of this sphere, the center of the earth, is the center of the world. And around this point, the center of the world, or the center of the earth, moves the whole sky. And it moves not because somebody moves it, but because ether has a natural inclination to rotational motion. So it is its nature to rotate. Well, this seems to be very clear now, because we are not taught this way at school. Whereas if you have in school the subject of astronomy, you start from heliocentric system of Copernicus, and you are given this picture, and you see that in the center there's the sun. You speak about solar system. In the center there's the sun, then follows Mercury, Venus, Earth with its satellite, the moon, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. So this is typically how the astronomy is taught at school. Nobody speaks with you about Aristotle, or only in bets, or just to show how stupid the medieval people were, that they had some queer and bizarre ideas of what is happening in the sky. Also, maybe there will be a lesson devoted to Galileo and his conflict with the Catholic Church. Yes, Galileo. But we can speak about the revolutionary discoveries of Galileo. For example, when using the telescope, Galileo discovered 4 satellites of Jupiter. And it was also a revolution, because I will explain of Jupiter. Because before Galileo, it was considered that there exist only 7 heavenly bodies, or 7, how to say, stars or planets: the sun, the moon, and Mercury, Venus, Mars, Jupiter, and Saturn. And there were 7 metals in alchemy: gold, silver, copper, mercury, iron, lead, and tin. And these 7 metals somehow corresponded to 7 heavenly bodies, okay? So there was a certain symmetry in alchemy. So the sun corresponded to gold, the moon corresponded to silver, Mercury corresponded to mercury, it's understandable, Venus corresponded to copper, Mars corresponded to iron, Jupiter corresponded to tin, and Saturn corresponded to lead. Okay, so these were 7 metals and 7 heavenly bodies. So when Galileo discovered 4 new heavenly bodies, no metals immediately appeared to correspond to these 4 satellites. So this idea, very popular in alchemy and used also in astrology, had to be somehow be said goodbye, you know, some discarded, okay? Well, this was also a revolution. Well, they are all examples, you understand, because later we'll speak in more details about what happened. But for today, I think it's enough just to have this idea of what is a revolution. And please do not forget these names of Thomas Kuhn and Alexander Koyle, because both these people speak about the revolutions. So if you read their books, you will get a more precise idea of what a scientific revolution is. And of course, we can speak about the scientific revolution of the 17th century, but we can also speak about the scientific revolution of the 20th century, the creation of special theory of relativity and quantum mechanics. But I think it's enough for today because I have overladen you with information, and I think we'll just have a nice Saturday evening and we'll meet next time. And thanks to Amshita for hosting us and taking trouble to organize the Zoom conference. I very much appreciate it. And thanks to everybody for listening to me. So I'm taking patience with my mistakes and my troubles. So I wish you every goodbye and hope to see you next Saturday.
Okay,
Goodbye.
thank you.
Thank you.